This is my geometry course. Today we're going to review linear equations, linear graphs, systems of equations, and equations with parentheses. We covered these topics in my beginning algebra course, but we're going to go over them again because linear equations and linear graphs are such an important part of the math curriculum, and they're also part of the geometry curriculum. And we're going to go over systems of equations and equations with parentheses because we're going to cover those topics in the next class. So we're going to do some practice with those topics today. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start by reviewing linear equations. In my beginning algebra course, we learned about the slope of a line. That measures the steepness of a line. So if a line is going up from left to right, the slope is positive. If it's going down from left to right, then the slope is negative. If the line is flat, the slope is 0. And if the line is vertical, then the slope is undefined. That's the case where you have like 3 over 0. That would be an undefined slope. Whenever you have 0 in the denominator of a fraction, the fraction is undefined. And this is the formula that you're going to use to find the slope given 2 points on the line. And we're going to go over that more later on. These are the 3 forms of linear equations. These are extremely important forms that all students need to learn. For example, we have slope-intercept form. That's a form where you can see the slope of the line and where it crosses the y-axis just by looking at the equation. For example, if you have a graph like so, the slope, this number, whatever it would be positive because it's going up from left to right. And this is the y-intercept. That's the number where it crosses the y-axis. So for example, you'll have 0, 3, for example, for the y-intercept, and this number here would be 3. Now the standard form we're not really going to use very much just because it's not a very useful form, but the point-slope form we're going to use quite a bit. And again, with the point-slope form, we have a lowercase m, just as with the slope-intercept form, because that m is the slope of the line. We can see the slope just by looking at that form. So go ahead and get a screenshot of all this information. You're going to need this screenshot throughout the rest of this class. And please do that because we don't want to have to keep going back to those problems. Now, let's do some practice. In these problems, we're just going to identify the form of the equation. So you need to get a screenshot of all these 3 forms. And we're going to identify which form each of these equations are in. So x and y are on the same side of the equation, so that is standard form. Y is by itself, so that is slope-intercept form. And again, x and y are on the same side of the equation, so that's standard form. So these problems are very easy. We're just learning how to identify the forms of the linear equations. So why don't you try numbers 4 through 6, and when you come back, we'll do them together. All right, we're back. This equation has parentheses, so it must be point-slope form. That's the easiest way to identify. And this equation has x and y on the same side, so it's standard. And this equation has y is isolated. So that's slope-intercept form. Again, these are just the easiest ways to identify the different forms. And there are other forms besides these 3, but we don't use those other forms really in the math curriculum. So now we're doing problems that are in slope-intercept form. All these equations are in slope-intercept form. So if they're in slope-intercept form, we can identify the slope and the y-intercept just by looking at the equation. So again, the y-intercept is where it crosses the y-axis, and the slope measures the steepness. This is slope-intercept form, and again, you should have that screenshot. So we can see the slope just by looking at this equation. It's the number next to the x. It's 4/3. So that means that the line is going up from left to right. And the y-intercept is 1. Again, because these equations are in slope-intercept form, we can see the slope and the y-intercept just by looking at them. The slope is 2 for this one, and the y-intercept is 3/8. Again, the slope is always the number next to the x. And the slope for this one is a little tricky because we can write this as 1/2 x. So 1/2 is is the slope for that one, and the y-intercept is -4. So these problems are very easy because they're in slope-intercept form. We can find the slope and the y-intercept just by looking at them. So why don't you try numbers 10 through 12, and when you come back, we'll do it together. All right, we're back. The slope is -4, and the y-intercept is -8. So if you got the right answer on that one, good job. And for this one, it's a little tricky. The slope is 4/9, but the y-intercept, there's no number, so it would just be 0. Because you can just write +0, and that's an equivalent statement there. So now, for number 12, the slope is -2/7, and the y-intercept is 5/6. So if you got the right answers on those problems, good job. All right, so now we're going to go in the opposite direction. Now they're giving us the slopes and the y-intercepts, and they're asking us to write equations. So here we're going backwards from the previous problems. We have y equals 2x plus 1/3. So that's mx plus b. We're just writing those equations in. And for the next one, y equals -2/5 x plus 4. And y equals -7x minus 3. So these problems, again, are very easy. And this should all be review for you. If you're rusty on this stuff, then that's okay. If you've never seen this stuff, that's not okay. You need to go back to my beginning algebra course and go over the stuff in more detail. We're kind of going through this stuff quickly because, again, this is all review. So if you want to, you can take a screenshot of those problems. Probably should, because the next problems we're not going to be in that window. So I want you to try numbers 16 through 18, and when you come back, we'll do them together. All right, we're back. Y is equal to 3/4 x minus 8/9. If you got the right answer on that one, good job. Y is equal to 1/6 x plus 2. You can also write that as x over 6. It's the same thing. So if you got the right answer on that one, good job. And y equals 5x minus 3.7. If you got the right answer on that one, good job. All right, so now we're going to point-slope form. Those were practice problems on slope-intercept form. This is point-slope form. Again, you should have that screenshot. And what we're doing is we're just finding the slope and a point on the line, the slope of the line, and a point on the line. So because these equations are in point-slope form, we can see the slope. That's 2/7. And we can also immediately see a point on the line, 5, 4. That's why this is called point-slope form. We can see the slope and a point on the line just by looking at that equation. So you might be thinking, why are we doing this? Well, the whole point is to get you familiar with those three forms. You're going to be required to know those forms in the math curriculum. Let's see here. So in this problem, the slope is the number next to the parentheses, so that would be -1/3. And a point on the line would be -9, +7. Now notice that the values in the point, they're opposite signs. So if you have a +9, it's going to be -9. If you have a -7, it's going to be +7. You may recall that from my beginning algebra course. That's the way it is with all these problems. So I want you to try 21 and 22, and when you come back, we'll do them together. All right, we're back. The slope is the number next to the parentheses, that's 5, and the point is 2, -3. So if you got that answer, good job. And for number 22, the slope is 5/12. The slope of the line and a point on the line is -4, -3. So if you got those answers, good job. All right, so now we're going to the same type of problems, no difference whatsoever, except we're going backwards. So in these problems, they gave us the equations and asked us to find the slope and a point on the line. But now they're giving us the slope and a point on the line and asking us to write the equation. So again, this is practice on point-slope form. So y minus 8 equals 4 times x minus 6. Again, I just plugged in the point, 6, 8, and I plugged in the slope. So these problems are very easy. Y minus 3 equals 6/11. Let me rectangle that. 6/11 x plus 5. And y plus 3 equals negative 6x minus 2. And those are some practice problems there for you to reference. So now why don't you try numbers 26 through 28, and when you come back, we'll do them together. All right, we're back. Y plus 3 equals 1/6 x plus 1. If you got that answer, good job. Again, we're writing point-slope form given the slope and the point on a point on the line. Y plus 9 is equal to negative 3/5 x minus 2. If you got that answer, good job. And y minus 7 is equal to negative x minus 7. If you got that answer, good job. Now, a lot of students may write negative 1 here, but you don't really need the 1. You can just write that negative sign. Either way is fine, but it's traditional to just get rid of that 1. So if you got those answers, good job. Now we're going to take standard form, which is really not a very useful form, and we're going to change it to slope-intercept form, because slope-intercept form is more useful. Then once we put it in slope-intercept form, we're then going to state the slope and the y-intercept, because if it's in slope-intercept form, we can see the slope and the intercept and identify them. So slope-intercept form is, let me find a good color there. Slope-intercept form is y equals mx plus b. We're trying to take this standard form. We're trying to take ax plus by equals c. This is standard form. And we're trying to convert to slope-intercept form. So we're going from here to here. So notice that in slope-intercept form, the y is by itself. The y is not by itself in this equation. We have to get that y by itself. We have to get rid of the 4x, and we have to get rid of the 2. So the first thing we're going to do is we're going to subtract 4x from both sides. Then we're going to divide both sides by 2 to get rid of that 2. And remember, when you take a polynomial and you divide by a monomial, you just divide each term. Again, this is all review from my beginning algebra course. So you can go back to that if you want to review that. But now it doesn't really look like slope-intercept form because the x term is on the right. So we're just going to switch that over. And now we have slope-intercept form. So that was part A of that problem. Now part B, we have to identify the slope and the y-intercept. Because this is in slope-intercept form, we can see the slope. The slope is negative 2, the number next to the x. And the y-intercept is 4. All right, so number 30. Again, we want to get the y by itself, so we're going to subtract 7x from both sides. Then we're going to divide both sides by 4, and we get 3/4 minus 7/4 x equals y. Again, you have to divide each term. And then we're just going to, I guess we can just flip it around just to make it more familiar. And we want to write the x term first and then the y-intercept because it's just traditional to do it that way. It'll be more familiar to you in reference to this equation up here. That looks right. And so that is slope-intercept form. That's part A of these problems. And then part B, now it's in slope-intercept form. So we can see the slope is the number next to the x, and the y-intercept is the other number. So that is the answer for number 30. So why don't you try numbers 31 and 30, or actually just try 31 first, and then we'll do it together, and then we'll go on to 32. Now, when you do number 30, make sure that this negative stays with the 5y. The most common mistake that students make is they make this negative somehow disappear. That stays with the 5y, so be careful with that one. So go ahead and try number 31, and when you come back, we'll do it together. All right, we're back. We have to isolate the y, so we're going to subtract 20x from both sides. And this is what I'm talking about. A lot of students will just make that negative disappear. No, it's still there. It's still with the 5y term. So now we're going to divide both sides by -5. So 25 divided by -5 is -5. -20 divided by -5 is +4. So that's where we came up with that. If you had trouble with those signs, again, this is all review stuff. So now we're just going to switch those around. And now we're in slope-intercept form. So because we're in slope-intercept form, we can see the slope and the y-intercept just by looking at that equation. So for part B, we can easily write the answer. It's the slope is the number next to the x, and the y-intercept is the other number. So if you got those answers, good job. If you had trouble with the signs here, I wouldn't be surprised by that, but again, that's a learning experience. Most students have trouble with those signs. So now go ahead and try number 32. I'm going to leave the other problems in the window, and when you come back, we'll do it together. All right, we're back. We're going to isolate y, so add 3x to both sides. And now we're going to divide both sides by 2. And looks like this is the first, well, I guess we had fractions in the other one. And we're just going to switch things around just to make it look like the traditional form there. We don't really have to, but again, it's traditional. So now we have slope-intercept form. That's part A, and we can easily identify the slope and the y-intercept. So if you got those answers, good job. All right, on to the next problems. So now we're given 2 points, a point here and a point here, 2 points on a line. And part A, we're going to find the slope of the line with those 2 points. Now that's where this equation comes in. Again, if you haven't taken a screenshot of these or all this information, go ahead and do that. We're now going to use this equation. That equation shows us how to find the slope given 2 points. We've found the slope just by looking at the different forms of linear equations. We did that in the previous problems, but now we're going to find the slope given 2 points on the line. There's a lot of different ways to find the slope. So we're going to use this equation. Again, it's that equation I just showed you over there. And we're going to plug in the points. So you can make 47.1 and 35.2, or you can make 47.2 and 35.1. It doesn't really matter. I'm going to make 47.1. So then we have x1 and y1 and x2 and y2. So then we have 5 minus 7 over 3 minus 4. And that gives us negative 2 over negative 1, which is just 2. So that is part A. We found the slope of the line that contains those 2 points. So now part B, it says to write the point-slope form of the equation. That's going to be really easy because we have the slope. Again, if we're going to write the point-slope form, we have to know a point and the slope. Now, is that really that difficult to understand or to remember? No, because it's called point-slope form. If it's called point-slope form, then all you need is a point and the slope. That's why it's called point-slope form. So point-slope form is y minus yp equals m times x minus xp. Again, that's part of your screenshot, and we did these practice problems. So now we can plug in the slope. We just found the slope. It's 2. So the slope is 2. And now it's important to understand we can use 3,5 or 4,7. We can use either of those. I'm just going to use 4,7 because that's the first point there. And we're done. That's point-slope form. So part B is pretty easy. Part C, it says convert convert point-slope form to slope-intercept form. So I'm just going to rewrite that point-slope form, and we're going to convert. So we have an equation with parentheses. I'm going to use the distribution rule, also called the distributive rule, to multiply. So 2 times x is 2x, and 2 times negative 4 is negative 8. Because the in slope-intercept form is y equals mx plus b. There are no parentheses, so we had to get rid of those parentheses. We also have to isolate y. Y is by itself in that form. So I'm going to add 7 to both sides, and that gets y by itself. So that is slope-intercept form. All right, let's do another one of these together before you try one on your own. So there are 3 parts to that problem. First, we're going to find the slope. And if I make 18.2, then we'll have 8 minus negative 2. Looks like we have a double negative there. So be careful with that double negative. Remember, double negative becomes a positive, so that's 8 plus 2 is 10. And 1 minus 6 is negative 5. And if we simplify, we get negative 2. So the slope of the line that contains these 2 points is negative 2. And now we have to write the point-slope form. So that's y. I'm going to use this point here, so that would be y plus 2. Remember, it's the opposite sign. X minus 6. So very, very simple. Very easy to write that point-slope form. Now we're going to convert that point-slope form to slope-intercept form. So I'm going to rewrite that point-slope form. And I'm going to get rid of the parentheses. So negative 2 times x is negative 2x, and negative 2 times negative 6 is positive 12. And I'm just going to add 2 to both sides, or subtract 2 from both sides of the equation. And that is slope-intercept form. All right, so again, 3 parts to those problems. So I want you to try number 35, and I'm going to leave those in the window. And when you come back, we'll do them together. All right, we're back. So part A, we're going to find the slope, making this point 2 and this point 1. We have negative 5 minus 11 over 3 minus 7. And that gives us negative 16 over negative 4, which is equal to 4. So that is the slope of the equation that contains those 2 points, or the slope of the line that contains those 2 points. Part B, we're going to write the point slope form, and I'm going to use 711, so y minus 11 equals the slope, which we just found, times x minus 7. So that's the answer to that one. And part C, I'm going to rewrite that point slope form and then convert it to slope-intercept form. 4 times x is 4x, 4 times negative 7 is negative 28. And I'm going to add 11 to both sides. And there you go. So if you got those answers, good job. Now try number 36, and when you come back, we'll do it together. All right, we're back. The slope using this as 0.2 is negative 3 minus 1 over negative 2 minus 4. That's negative 4 over negative 6, it looks like, which simplifies to positive 2/3. Part B, we're going to write the point slope form. I'm going to use the first point. And then the last point, or the last part, we have to write slope-intercept form, so I'm just going to rewrite point slope form. And looks like this is the first case where we have a fraction for the slope, so I'm sorry I gave you that particular problem there, but 2/3 times x is just 2/3 x. That's very easy. But 2/3 times negative 4, you may have had trouble with that. This is something that you should know. Again, we learned this in my arithmetic course, but all you're doing is just multiplying a fraction by a whole number. A lot of students have a meltdown when they see that, but whenever you have a whole number, you can just write it as 4 over 1, or the whole number over 1. And then remember, when you multiply fractions, you just multiply straight across. So 2 times 4 is 8, and 3 times 1 is 3. These are all things that you should know at this point in the curriculum. All right. I guess I can leave all that. So now we just have to get the 1 on the other side. So y is equal to 2/3 x minus 8/3 plus 1. We have to add 1 to both sides. Now we just have to combine these. And that's another thing you may have had a little trouble with. Negative 8 thirds plus 1. 1 is just 1 over 1. And you can multiply both sides by 3 to get 3 over 3. Why do we do that? Because we need a common denominator. Remember, when you add fractions, you need a common denominator. There's a lot of different ways to do this, by the way. I'm just doing it the way that is easiest to understand. Then we're going to add these two together, and we get negative 5/3. Because negative 8 plus 3 is negative 5. And we just keep that fraction there. So that part C there was a little weird, but if you got the right answer, good job. If you didn't, that's okay. Just figure out what you did wrong. And on to the next problem. So now we're going to graph. Those previous problems were just reviewing forms of equations, but now we're actually going to take linear equations and graph them. And if you recall, in my beginning algebra course, we learned 4 methods for graphing a linear equation. So there's quite a few ways to do this. Now we're going to attempt method number 1. We're going to use 2 random points. And sometimes they're random, sometimes they're not so random, but let's see, I'm going to choose, I'm going to say x is equal to 1. That was just a random x value that I chose. So now I'm going to plug that into this equation. So we chose we choose x is equal to 1. So now we're going to plug it into the equation. So we have 2 times 1 plus y is equal to 1. 2 times 1 is 2. Subtract 2 from both sides, and we have y is equal to -1. So what does that mean? Well, it means the point that we just found is 1, -1. And we can plot that point later on. Now we're going to choose a second point. Actually, let's go ahead and plot it now. So 1, -1 would be here. That is 1, -1. Now we have to have 2 points to graph a line. If we find the point is over here, we connect the dots and we're done. But we can't graph a line with just 1 point, so we have to find another point over here. So we tried plugging in x equals 2. Now we have to try plugging in x equals something else. And by the way, you don't have to start with the x value. You can start with the y value if you want. So let's try x is equal to, let's try -1. So now we plug in -1 instead of 1. Here we plugged in 1, here we plugged in -1. And plus y equals 1. 2 times -1 is -2. And add 2 to both sides, and we get y is equal to 3. So the point is -1, 3. So now we plot that point. That's up here. That looks correct. So now we can connect the dots, and there we go. The line doesn't have to be perfect, but something like that. So that is the method where you just choose 2 random points. So I want you to try that method yourself. So I want you to try 38. And again, you're going to choose those 2 points and graph that line. So do your best, and when you come back, we'll do it together. All right, we're back. So I'm going to choose x equals 1, I guess. And you may have chosen different points, but I forgot to mention you can't choose like 100 because 100 is outside our window. You may have noticed that. But you didn't have to choose 1. You could have chose something else. But when we graph the line, it has to look like the same line that I graphed. So y is equal to -2. So therefore, our point is 1, -2. All right, so 1, -2 is down here. I'm going to go ahead and plot that, or label it 1, -2. And for the other point, what should we choose? Let's see, I'm just going to choose the same numbers I chose before. Well, maybe I should choose something different. I'll choose -2. So x equals -2. And I'm going to plug that in. So we get 2 times -2. Y equals 2 times -2 minus 4. 2 times -2 is -4. And -4 minus 4 is -8. So the point that we just found is -2, -8. And I just realized that's outside of the window. You see what I'm talking about? 2, -8 would be all the way down here. So if you find that you're outside the window, that's okay. Just go back and try some other point. I'm going to try 2. So y equals 2 times 2 minus 4. And we get, I'm just going to rush forward there, it's 0. So our point is 2, 0. So 2, 0 is here. And in order to make the line straight, you can kind of, we're going up and over, up 2 over 1. So you can kind of make some more dots here, just so to make sure that it's straight. And connect the dots. Again, your line doesn't have to be perfectly straight. Don't waste a lot of time with a ruler or something making your line perfectly straight. We don't have time for that. So if your line looks something like that, Good job. All right, so that was method 1, using 2 random points. They're not 100% random, because if you chose like 100, for example, obviously, like I said, that would be out of the scale. Now let's try method 2. Method 2, we are finding x and y intercepts. So it's really the same exact method. There's no difference whatsoever, except you're choosing special values, not just completely random values. You always choose 0, all right, for x. So now we're going to plug in 0 to the equation and find what y equals. So negative 0 over 3 is just 0. And then we get y is equal to negative 2. So the point is 0, negative 2. But that's not just any point. That's a special point. That's the y-intercept. It's special because it's on the y-axis. So method 2 is finding the x and the y-intercepts. So now we're going to choose. Now this is something different. In the previous problems, we chose x first. We plugged in an x. But remember, I told you could plug in y too. In these particular problems, we're now going to choose y first on this second part. And we're going to let y equal 0. You have to choose 0 for x and 0 for y. That's just how this method works. So now we're not plugging in x. Instead, we're plugging in y. That's the y value. We're plugging in 0 for y. Now we have to add 2 to both sides, because this equation is going to be a little bit more difficult to solve than the previous problems. And then we're going to multiply both sides by negative 3, because remember, you can take this negative and you can put it down there and just pretend it's with a 3. So we're getting rid of the negative and the 3. Multiply both sides by negative 3, and we get x is equal to negative 6. So our point is negative 6, 0. Be sure not to mix up the x and the y value. Remember, the x always comes first, and the y always comes second. So now we have negative 6, 0. Now that's not just any point. That's a special point, because that is the x-intercept. Why is it the x-intercept? Because it's on the x-axis. So again, these are not just any points, they're special points. All right, so now we just connect the dots. And again, your line doesn't have to be perfect. Don't spend all day with a ruler trying to make this perfect. So now I want you to try that method. Again, you have to let x be 0 and you have to let y be 0 on those 2 points. If you don't do it that way, then you're not using the method correctly. So try number 40, and when you come back, we'll do it together. All right, we're back. So we're going to choose not just any x value, but we're going to choose x equals 0. And over here, we're going to choose y equals 0. So if x is 0, we have 3 times 0 plus y is equal to 3. This is 0. 3 times 0 is 0, and then y obviously equals 3. So we have 0, 3. Over here, well, let's go ahead and plot that. 0, 3. And then over here, we're going to choose 0 for y. So we have 3x plus 0 equals 3. 3x equals 3, and x equals 1. So the point is 1, 0. Don't confuse your x and y value. 1, 0 for the second point. And now we just connect the dots. So we're going down 3 and over 1. So we can use that to make a straighter line. So now we just connect the dots. And there you go. So if your line looks something like that, good job. Remember, for the previous method, you could use any points as long as they're in the window. But for this method, you can't use any point. You have to use these special points. So in these problems, in the problem you just did, you have to have 0, 3, and 1, 0. You can't have any other points. So in the homework, when I tell you to use the x and y method, you have to have those particular points. All right, so now it's time to try the easier methods. Method 3 is a lot easier than the previous methods. For method 3, we're going to use slope-intercept form. And notice we already have slope-intercept form. That's y equals mx plus b. Because it's in slope-intercept form, we can see the slope, we know what the slope is, and we know the y-intercept. So we can use that information to graph the line very easily. So we're going to start with the y-intercept, which is 3. That's where it crosses the y-axis. And then we're going to use the slope. The slope is 2. So maybe I'll just write that. Slope is 2, y-intercept is 3. And you can write the slope as 2 over 1. Now, with this method, what we're going to do is we're going to use rise over run. Slope is often considered rise over run. So the rise is 2. And let me use my green marker there. The rise is 1, 2. And the run is 1. So then we mark that point and we just connect the dots. And you're done. But just to make it a little straighter, we're going to do a rise over run on more of these. So up 2 over 1 will get us there. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. That'll just help us make the line straighter. You can do a bunch of those triangles just to make the line straighter. But don't use a ruler. We don't have time for a ruler. All right, so that is the slope-intercept method. You can see it's a lot easier. This point was 0, 3, and this point was 1, 5, because we went over 1, and then we went up 2, so we had to increase the 3 to 5. All right, so go ahead and take a screenshot of that because I'm going to leave that window. I want you to try a problem like that. But you have to have that problem as a reference. So again, we're going to try method number 3. Go ahead and try number 3, and when you come back, we'll do it together. Remember, you're going to plot the y-intercept first, then you're going to use rise over run to find the second point with a triangle. Now, when you do your triangle, be sure that you go down. You want to go down and then over, not up and over. Because this slope is negative, so the line should be going down. It should be going this way. So make sure that you go down 3 and over 4, not up 3. So be aware of that one. So try number 42, and when you come back, we'll do it together. All right, we're back. So we're using slope-intercept form. We can see the slope is -3/4, and the y-intercept is -1. We can see that just by looking at that equation. So -1 is the y-intercept. We'll just plot that point there. So that is 0, -1. And the slope is -3/4. So we're going to go down. And let me extend this down a little bit, this axis. We're going to go down 3, 1, 2, 3. And over 4, 1, 2, 3, 4. And that gets us to the other point. And again, to make the line straighter, we're going to go up 3, 1, 2, 3, over 4, 1, 2, 3, 4, and mark that. And then just connect the dots. And we should mark this point. So we started at 0, -1. We went over 4, so I know the x value has to be 4. And then we went down 3. So we started at -1. If we go down 3, we're going to end up at -4. So I know that that point has to be 4, -4. And you can see it is 1, 2, 3, 4, 1, 2, 3, 4. So if you got that answer, good job. But the trick to that one is we're actually going down from left to right because the slope was -3/4. All right, so now we're going to attempt the last method, which is using point-slope form. And we have point-slope form here, so we can see the slope and a point on the line just by looking at that equation. So again, point-slope form is like so. And so we can see the slope is -5/2, and we see a point on the line, which is 1, -2. We can see all that stuff just by looking at this equation because it's in point-slope form. So now I'm going to first plot the point. So the point is 1, -2 right there. And then I'm going to use the slope to find the other point. So the slope tells us the rise is -5 and the run is 2. So it's negative, so I have to go down. So 1, 2, 3, 4, 5, and then over 1, 2. But notice I'm out of the scale. If I'm out of the scale, that's okay. I can just go in the opposite direction, and I can go up and to the left. If I go up and to the left, 1, 2, 3, 4, 5, 1, 2, then that will give us a point that we can use to graph the line. So that point is -1, 3. And just connect the dots. But before we connect the dots, let me go up a little bit more, or get another reference point. 1, 2, 3, 4, 5, 1, 2 is about up there. And connect the dots. So again, that was an important point. If you go off the scale, when you're trying to use your slope, you can go the other way, up instead of down and to the right, you can go up and to the left. Same thing with a positive line. If you go off the scale, when you go up and to the right, then you can just go down and to the left. And if that doesn't work, then you just have to write a different scale for your graph. So that was point-slope form. So I'm going to leave that problem in the window, and I want you to try number 44. Now be aware. Let's go ahead and write out that point-slope form. I guess we don't have to write the general equation again, but I'm just going to do it so you can see what we're using. The slope is 4, right? But to do rise and run, remember, whenever you write a whole number, you have to write the whole number over 1. So the rise is 4 and the run is 1. So go ahead and try number 44, and when you come back, we'll do it together. All right, we're back. So a point on the line is -5, 2. The slope is 4, so let's plot -5, 2. That's here. So -5, 2. And then we're going to use the slope. We're going to go up 4, 1, 2, 3, 4, and over 1. So this is kind of a steep line. And then we'll just connect the dots. Let's make one more point. And connect the dots. And there you go. And let's go ahead and plot this point. So we started at 2 and we went up 1, 2, 3, 4. So that would be, and we went over to the right 1. So we started from -5 and we'll go to -4. We started at 2 and we went up 4. So that would be 6. So if you got those answers, good job. All right, so those were the 4 methods for graphing linear equations. So now we're going to go backwards. In the previous problems, you were given a linear equation and you were asked to graph it. But in these problems, you're given the graph and you're asked to find the linear equation. So we need some practice with that. With this problem here, it's really easy because we can see the y-intercept. We can also see the slope. If I just, let me get a different color there. If I just go up 1 and 1, 2, 3 to the right, I can see the slope is going to be 1/3. So if we have the slope and we have the y-intercept, we can just write y-intercept form or slope-intercept form. So y is equal to the slope, which we found is 1/3. Then put your x, and plus 3 because the y-intercept is 3. So again, we just wrote slope-intercept. We use slope-intercept form. So when the graph crosses the y-axis at a corner, we can use that slope-intercept form. But in this case, the line does not cross at a corner of a square. You see that? So we can't use slope-intercept form. We have to use point-slope form. And we can choose any one of these other points. So it doesn't really matter which point you choose as long as it's an actual point on the line. And in this case, we're using point slope. So y minus yp is equal to m times x minus xp. Again, we're using point slope because we can find just some random point that's on the line as opposed to the special y-intercept point and the slope. So let's see what the slope is. The slope is down 1, 2, 3, and then over 1, 2. So if it's down, that means it's going to be negative, and I can use any one of these orange points. So I guess I'll just use that point there. So that point is 1, 3. So we have y minus 3 is equal to the slope, which was negative 3/2 times x minus 1. And let me rectangle all these. So again, you might have to use, you can use the slope-intercept form if you have that case where the line crosses at the y-axis at a corner of a box. But if it doesn't cross at a corner of a box, you have to use the point-slope form. So in this first problem here, we can use the slope-intercept form. So go ahead and try number 47, and when you come back, we'll do it together. All right, we're back. Again, you can use slope-intercept form. We know the intercept is -1, so we have y equals, we know it's -1 over here. And then now let's find the slope. So we have 1, 2, 1, 2, 3, 4. So that's -2 over 4. And then you can just simplify it. -2 over 4 is -1/2. And by the way, you can also write that as negative x over 2 minus 1. That's the same thing, but I'm just going to leave it in that previous form. So if you got that answer, good job. Now for number 48, notice that the line does not cross a corner of a box on the y-axis. So that means you're going to have to use this method up here. So go ahead and try number 48, and when you come back, we'll do it together. All right, we're back. So I'm going to use this point. That point is 1, 2, 3, 4, -1. And the slope, let's see what the slope is. We can go up and over like this, or we can go down and over. It doesn't really matter. So let's go up. I'm going to do 1, 2, 3, 1, 2, 3, 4, 5. So it looks like 3/5 is the slope. So we have y minus or plus 1 equals 3/5 x minus 4. Now I want you to be aware that if you used a different point, you may have gotten a different answer. This point over here is -1, 1, 2, 3, 4, -4. So if you use that point, you got a different answer. You should still have the same slope, but you may have gotten a different answer. So you may have gotten y plus 4 is equal to 3/5 x plus 1. If you got that answer, that works too. So if you got either of those answers, good job. All right. So now we're going to special lines. These are vertical and horizontal lines. So we're going to do the same thing. We're just going to write the equation of these lines. This is a horizontal line at y equals -2, so we just write y equals -2. Pretty easy on that one. because the y value of all these points, the y value of all these points is they're all the same. They're all -2. So we just say y is constantly -2. That's the logic behind that. So for the next line, we have a vertical line at 4. X is always equal to 4 for all those points. So we just write x is equal to 4. For every single one of these points, x is equal to 4. So that's why we can just write it as x equals 4. Again, the forms of the equations for vertical and horizontal lines are special forms. All right, so why don't you try number 51 and go ahead and try 52 also, and when you come back, we'll do them together. All right, we're back. This is a horizontal line, so it's y equals 1. This is a vertical line, so it's x equals -2. Again, this is just memorization, memorizing how to write vertical and horizontal lines. So those should not be difficult for you. All right, on to 53. 53, now we're graphing. So now we're going backwards from these previous problems that we just did. They gave us the graphs here, and we had to write the equations, but now they're giving us the equations, and we have to draw the graphs. So it's not too bad. It's pretty easy. Y is equal to 2. That would be here. So that was pretty easy. And x is equal to -5. So 1, 2, 3, 4, 5. That would be out here. That's pretty easy. And so why don't you try numbers 55 and 56, and when you come back, we'll do them together. All right, we're back. So x is equal to 1. That's a vertical. And some students might be asking, well, how do I remember which is which? Well, you just remember. You just use your brain. I can't make you memorize these things. You just got to memorize them on your own. That is the horizontal line. So if you got those answers, good job. All right, so now we're going to do one more thing today. We're going to do systems of equations, because we're going to need this for the next class. And also, systems of equations are a pretty big part of the math curriculum, so it's good to review these things. Now let's talk about what systems of equations are in the first place. So we have a bracket here, and that bracket means that these two equations go together. And what this is asking us to do is it wants us to find x and find y. So we have to find both x and y. And because we have two equations, we can figure out what those two variables are. Now, there's three methods that we learned in beginning algebra, in my beginning algebra course, to solve systems of equations. The first method is substitution. The second method is elimination, or also called addition, and the third method is graphing. Now the graphing method is when you graph both lines, and then you find the point where they intersect, and that point has an x and a y value, and whatever that x and y value are, that's the solution. That's the x and that's the y, which is what we're looking for. But that method is unreliable. It takes a long time to do, and it's unreliable because the lines have to be, the graph has to be really accurate. And so we're not going to use the graphing method. And the elimination method, we're just not going to use that today because we're not going to need it for the next class. We're just going to stick with the substitution method. So you may think, well, I don't really remember what the substitution method is. That's okay. We're going to go over it now. You use the substitution method when one variable is solved for. So x is by itself on the first equation. Typically, you use the elimination method when you have something like this. When both equations are in standard form, that's typically when you would use elimination, but we don't have that here. We have equations where one variable is isolated, so it's better to use substitution. So what we're going to do is we're going to take the equation where x is not isolated, this one, and we're going to rewrite it. But then we're going to, instead of x, we're going to plug in what x equals, what the first equation tells us x equals. So we're going to take 2y and we're going to plug it in there. So again, I'm just writing this equation, but I'm plugging in 2y for x. Why am I plugging in 2y for x? Because I know that's what x equals. That's what the first equation tells us. So now we have 2y minus 3y is negative 1y. Then we just divide both sides by negative 1 and we get y is equal to negative 1. So we found y. Now to find x, I'm going to take the first equation and I'm just going to plug in what y equals. And then we have 2 times negative 1 is negative 2, so x equals negative 2 and y equals negative 1. And it's very common to write the solution in coordinate form, so I'm going to go ahead and do that. And that is the solution for that first problem. All right, so let's try one more of those before you try one on your own. Again, this should be fairly familiar. If you're rusty with it, that's okay. So we're going to use the substitution method because in the bottom equation, x is by itself. A variable is solved for. So I'm going to take the other equation where x is not solved for, and I'm going to rewrite it. But then instead of plugging in x there, I'm going to plug in what x equals. So again, I just rewrote this equation, and then I plugged in what the second equation tells us x is. So I put 3y minus 4 into that x. Then I'm going to, now I have an equation with parentheses. Notice in the title for this class today, we said that we're going to go over equations with parentheses. So now that's what we're doing. In order to solve this system, we have to solve the equation with parentheses. So we're going to use distribution, negative 5 times 3y. The first thing you do when you have an equation with parentheses is get rid of those parentheses. So negative 5 times 3y and negative 5 times negative 4. So negative 5 times 3y would be negative 15y. And negative 5 times negative 4 is positive 20. Then just rewrite the other part. And then negative 5y plus 2y is negative 13y. And now we just have a two-step equation. Subtract 20 from both sides, divide both sides by 13, and we get y is equal to 18 over 13. So now we have the y value. And we just have to find the x value. So now we take the second equation where x is actually solved for and rewrite it down here. We have x is equal to, I'm going to move this over a little bit, we're going to need a lot of room. X is equal to 3 times the y value, which we just found, minus 4. So you can write this 3 as 3 over 1. And then you're just going to multiply straight across. So 3 times 18 and 1 times 13. So we end up with 3 times 18 is 54, and 1 times 13 is 13. Then we have 54 over 13 minus 4. And you can just write the 4 as 4 over 1, multiply both sides by 13. And you end up with 52 over 13. 54 over 13 minus 52 over 13 is 2 over 13. So we have 2 over 13. And so the final solution is 2 over 13. Sorry, this is so cramped in here. And 18 over 13. So I'll go over back over that and make it a little neater if we have time. But Now, I know what you're thinking. You're thinking, I don't like all that arithmetic. I don't like all those fractions. Well, you're just going to have to get used to it. You should know how to do all that stuff by now. That's just basic arithmetic you learned in my arithmetic course or some other arithmetic course. If you didn't learn that in an arithmetic course, then you're just going to have to go back to my course and learn it. All right, so on to number 59. Now it's time for you to try, but I want you to be aware that in these two problems, x was isolated. You see the x here? X is by itself, but in the next problem, y is going to be isolated. So it's going to be a little bit different. You're going to plug in all this to here. So this is the equation where a variable is isolated. So you take the other equation and you rewrite it, the 4x plus y equals 2. You rewrite that. But instead of writing y, you're going to write what y equals. So try number 59, and when you come back, we'll do it together. All right, we're back. So I'm going to take the other equation where the variable is not solved for, and I'm going to rewrite that. But instead of y, I'm going to plug in x plus 1. Now I'm just going to simplify. 4x plus 1x is 5x. And subtract 1 from both sides, divide both sides by 5, and we get x is equal to 1/5. And now I just have to use, I'm going to use the second equation to find y. That's just the easiest way to do it. So y is equal to 1/5 plus 1. And just to save time, we can just write that as 1 and 1/5. Remember, you can write mixed numbers if you want. Traditionally, you don't write mixed numbers in algebra, but you can if you want to. So the final solution is 1/5, 1 and 1/5. So if you got those answers, good job. Now, 1 and 1/5 can also be written as 6/5. So if you wrote 6/5 here, that's fine. So if you got that answer, good job. If you didn't get that answer, that's okay. Just figure out what you did wrong. So now, why don't you try number 60? And I'll leave those other problems in the window. And when you come back, we'll do it together. All right, we're back. So this is the equation where a variable is solved for. Again, we have y is solved for something. So we're going to take the other equation where y is not solved for, and we're going to rewrite it. But instead, I'm going to plug in what the first equation tells us y equals. So that's 2x minus 3. And now I have an equation with parentheses, so the first thing to do is get rid of the parentheses using distribution. So I'll just rewrite the 4x, then we get 4 times 2x is 8x, and 4 times negative 3 is negative 12. And then 4x plus 8x is 12x. And then we're going to add 12 to both sides and divide both sides by 12, and we get x is equal to 19 over 12. And so now we're going to take the first equation where y was actually isolated, because that's just the easiest way to do it. And we're going to find y. So y is equal to 2 times x, and we found x is 19 over 12 minus 3. And if we do the math on that, we end up with, looks like it's going to be 1 over 6. So the final solution is 19 over 12 and 1 over 6. Again, we're writing it in coordinate form. So I know you don't like the fractions. Nobody likes to have to deal with fractions. I don't like to have to deal with fractions, but you just got to do it. So if you had trouble with those, again, you can go back to my arithmetic course and review fractions if you need to. All right, so now we're going to go on to some problems that are quite different from the systems that you're used to. They're not hard to solve, but they're just different. The systems that I gave you in my beginning algebra course were specifically designed for a particular purpose, but not all systems are going to look exactly alike. They're not going to look exactly like the ones that I gave you. So here's an example. We're going to solve this equation the same way. We have an equation where a variable is solved for. So I'm going to rewrite the other equation just like we did before. So we have 2y is equal to x plus 3. But then, instead of x, I'm going to plug in what x equals, what the second equation tells us x equals. And the difference here is now we have y's on both sides of the equation. That's the difference. But that's okay, because all we have to do is just get all the y's on the same side. So we're going to subtract 4y from both sides, and we get negative 2y equals 3. And divide both sides by negative 2, and we get y is equal to negative 3/2. And then to find the x value, I'm just going to plug it into that second equation. And you can plug it into the first equation if you want. I didn't mention that, but it's just harder to use the first equation. Equals x. And if you do the math on that, we get negative 6. I don't have the room to do all the math on that, but again, that's just arithmetic. You should if you're having trouble with the arithmetic, you can just go back to my arithmetic course where we learn how to do fractions and whatnot. Again, arithmetic is a prerequisite for this course. So if you're complaining that there's too much arithmetic, that you need to go back to my arithmetic course. All right, so I want you to try one of those problems. Again, the only difference is you're going to have variables on both sides of the equation. So try number 62, and when you come back, we'll do it together. All right, we're back. So y is isolated with this equation, so we're going to take the other equation, and we're going to rewrite it. But the difference is, instead of y, we're going to plug in what y equals. So negative 3x. Let me move that over a little bit. Now we have an equation with variables on both sides. That's the difference. That's what's different about these problems from the problems I gave you in my beginning algebra course. And again, we're doing this because we're going to see this in the next class. So now we want to simplify the right side of the equation first. 2 times negative 3x is negative 6x. Now we have variables on both sides, so we have to get them all on the same side. Add 6x to both sides, and we get 4 plus 7x. And subtract 4 from both sides, and we get, well, we can just, that's a two-step equation. We can just do 2 steps at once. So we get negative 3/7. Now we're going to use the other equation. I should have made an arrow for that one. So y is equal to negative 3 times the x value, which is negative 3/7, and that just equals positive 9/7. And we don't have room to write the ordered pair, so I'm just going to leave the answers like that. So x is negative 3/7 and y is 9/7. All right, so now we just have 4 more problems to do here. These problems are more like the ones that we're going to do in the next class. We're going to use the substitution method again, but in these problems there's no variable that's solved for, you see. We can't use the substitution method. There's no variable that's isolated, that's by itself. So what we're going to do is we're going to take one of these equations and we're going to actually isolate the variable. You may think, well, what about elimination? Can we use the elimination method? Well, they're not in standard form, so it doesn't really make sense to use the elimination method. And the graphing method, like I said, takes too long and it's not reliable. So all we can do is just solve for one of the variables and use the substitution method. So in the top equation, I'm going to add 3 to both sides. Now I could isolate the second equation. I could isolate y in the second equation. You'll get the same answer. But I'm just going to choose the top equation. So I'm going to rewrite the exact same equation. except now I isolated y by adding 3 to both sides. Then I'm just going to rewrite the bottom equation. So again, I just rewrote the same system of equations, no difference whatsoever, except I put this 3 on the other side, and now y is isolated. So now that y is isolated, I can use substitution. So now I'm going to rewrite the equation where y is not isolated. Y minus 7 is equal to 2 times x minus 2. But now, instead of y, I'm going to plug in what y equals. So y equals all this stuff. I'm going to plug it in there. So 3x minus 4 plus 3, and then minus 7 equals 2 times x minus 2. So all of this stuff here is y. I plugged in all that stuff. So now we have an equation with parentheses. That's why we're reviewing the equations with parentheses here. So now, remember, when you have an equation with parentheses, the first thing you got to do is get rid of those parentheses. So we're going to use distribution here. 3 times x is 3x. 3 times negative 4 is negative 12. Then you can just rewrite the other parts. 2 times x is 2x. 2 times negative 2 is negative 4. So now we're going to combine all of these. Before you start putting stuff on other sides of the equation, combine. Negative 12 plus 3 is negative 9. Negative 9 plus negative 7 is negative 16. And now we have variables on both sides of the equation. We can't have variables on both sides of the equation, so we have to subtract 2x from both sides, and we get x minus 16 equals negative 4. Add 16 to both sides. We're going to put the other variables, the regular numbers, on the other side. Add 16 to both sides, and you get 12. So x is equal to 12. So that is one of our solutions, and now we just go to the equation where y is isolated, and we're going to rewrite that one to find the y value. So y is equal to 3 times x minus 4 plus 3. But now I'm going to plug in what x equals, so we're just doing the same thing we did in the previous problems. And then now we have to follow order of operations. So order of operations, PEMDAS, parentheses first, 12 minus 4 is 8. And then PEMDAS tells us to do exponents. We don't have exponents. And then multiplication. We have multiplication. 3 times 8 is 24. And 24 plus 3 is 27. So writing as an ordered pair, our final solution is 12, 27. So again, the purpose of that problem is just to get you ready for some problems that we're going to do in the next class. All right, so try number 64. I'm going to leave 63 in the window. Again, you want to isolate y in one of these equations. You can isolate x also, but that would be a lot harder. So you want to isolate y. You can subtract 1 from both sides here, or you can add 2 to both sides here. You can isolate y in the top equation or the bottom equation. It doesn't matter. But then you plug in to the other equation. So again, I'm going to leave 63 in the window. Try 64, and when you come back, we'll do it together. All right, we're back. I'm just going to isolate y in the top equation. So I just rewrote the system. I just changed this equation a little bit by isolating y. Now I'm going to rewrite the second equation where y is not isolated, and I'm just going to plug in what the top equation tells us y equals. So that would be 2x minus 1, and then minus 2. So again, all of this stuff here, I plugged in to here. So now we just have to simplify. We have an equation with parentheses, so we just have to get rid of the parentheses. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. 2 times x is 2x. 2 times negative 1 is negative 2. And then we have negative 1 minus 2. So now we're just going to combine all of this stuff. Negative 1 minus, or negative 2. Negative 2 minus 1 is negative 3. Negative 3 minus 2 is negative 5. And I'm going to add 3x to both sides. Add 5 to both sides. Divide both sides by 5, and then we get negative 2. So x is equal to negative 2. So now I'm going to take the equation where y was solved for, and I'm going to rewrite that, but I'm going to plug in what x equals. We know x equals negative 2. So now we do PEMDAS, parentheses first. Negative 2 minus 1 is negative 3. And then we get negative 7. Just jumping forward with the math there. We don't have a lot of time. Negative 2, negative 7, written in ordered pair form, that's the solution. So if you got that answer, good job. If you didn't, that's okay. Just figure out what you did wrong. All right, so the last two problems today are going to be exactly what we just did, but now we might end up with some fractions in these problems. I just want you to be aware that sometimes you are going to have to deal with fractions in these particular problems. So I'm going to rewrite the system, but on the top, I'm going to isolate y, and I'm just going to rewrite the bottom equation. Now I'm going to take the equation where y is not isolated, and I'm going to rewrite that, but now we're going to write what y equals. So I took what y equals, and I plugged it in there. All right, so now we have an equation with parentheses. We just have to solve the equation. We got 6x plus 18 is equal to negative 2x plus 6 plus 5 minus 3. I'm going to simplify all this, and we get, looks like 8. And then I'm going to add 2x to both sides. We get 8x. Subtract 18 from both sides. We get negative 10. And then we're going to divide both sides by 8. And we get negative 5 over 4. So the difference with this problem is now we have a fraction. And I know that we're not too excited about fractions, but we just have to deal with them. We don't have a choice. So now I'm going to write that top equation because y is isolated. It's just going to be easier to use that top equation. And now we're just going to follow order of operations. Combining these is probably going to be the hardest part for most students, even though, again, this is just arithmetic stuff. You should know this. Negative 3 becomes negative 12 over 4. So negative 5 over 4 minus 12 over 4 is negative 17 over 4. And, whoops. Now we're just going to multiply negative 17 over 4 by 2. And if you do all the math on that, we get positive 17 over 2 plus 5. And this next part is going to be another issue. I mean, combining these is going to be an issue. Multiplying these is usually an issue, and adding these is an issue. But this is all arithmetic. It's all arithmetic. So you can go back to my arithmetic course and review that if you want. So if you get a common denominator, again, whole number, you can just write it as over 1, multiply both sides by 2, and you get 10 over 2. So 5 becomes 10 over 2. 17 over 2 plus 10 over 2 is 27 over 2. So y equals 27 over 2. And if you want to, you can write it as a decimal. That would be 13.5, but I'm just going to leave it as a mixed number. All right, so writing as a ordered pair, our final answer would be negative 5 over 4 and 27 over 2. All right, so I know you don't want to do this. I know it's not going to be fun, but you are going to have to do this problem, and there are going to be fractions. But this is the last problem for today, so try number 66. Again, you can isolate y in the top equation, or you can isolate it in the bottom equation. You're going to get the same answer. I've always been isolating the y in the top equation, so you may want to stick with that. Try number 66, do your best, and when you come back, we'll do it together. All right, we're back. So I'm going to rewrite the system, except I'm going to isolate y in the top equation. And then I'm going to take the equation where y is not isolated, and I'm going to rewrite it. You don't have to do that step if you don't want to. I just want to make sure that you know what I'm doing here. And now I'm going to rewrite the equation, except instead of y, I'm going to write what y equals. The first equation tells us y equals. So I just plugged in y there. And minus 3 is equal to negative 5 times x minus 2. So I took what y equals, and I plugged it in for y here. So that's what y equals. Now we have an equation with parentheses. We just get rid of the parentheses. And I'm going to combine all of this stuff. 2 minus 1 is 1. 1 minus 3 is negative 2. And now I'm going to add 5x to both sides and add 2 to both sides. And we get 7x is equal to 12. Divide both sides by 7, and we get x is equal to 12/7. Now I'm going to take the equation where y was isolated, and I'm going to rewrite it down here. So y is equal to 2 times x plus 1 minus 1, but now I'm going to plug in. I guess I didn't have to write that part. Y is equal to 2 times x is going to be 12 over 7. So now, again, there's a lot of issues that students have because they're kind of lacking when it comes to the basic arithmetic. Hopefully you're not lacking, but 1 is just going to be 7 over 7. So 7 over 7 plus 12 over 7 is 19 over 7. Now we have to multiply. That's just 2 over 1, so multiply straight across. 2 times 19, 1 times 7. 2 times 19 is 38. 1 times 7 is 7. This 1 just becomes 7 over 7 again. 38 over 7 minus 7 over 7 is 31 over 7. So writing the answer as an ordered pair, we have 12 over 7 and 31 over 7. So I know that was kind of a challenge, mostly because of the fractions. So if you got number 66 right, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. If you did something wrong, it's probably going to be with this arithmetic here. All right, so that was the class today. Let's go ahead and look at the homework. Actually, let's go over, and if you want to take screenshots of all the work that we did today, you can go ahead and take those screenshots now. Now let's look at the homework. Go ahead and get screenshots of this homework. And here's the answers for numbers 14 through 34. Be sure to do that homework completely and correctly and neatly, and be sure it's in the proper order in your binder. Remember, if you don't do the homework, it's a 100% guarantee that you're going to learn absolutely nothing in this entire course. So that said, I'll look forward to seeing you in the next class.